Hello everyone. In this video I am going to show you how to analyze a truss using method of joints. So this is the example 2 problem. And this is my truss, and you can see there are 3 point loads here at joint G, F and E. 3 kilonewton, 2 kilonewton and again 3 kilonewton. And there are 2 supports at A and D. At A there is a pin support, and at D there is a rocker support. When we have a pin support, we usually mark 2 force component or reaction components, which are horizontal force component and vertical force component. At the rocker support, we usually mark one support reaction, which is a vertical support reaction or vertical force reaction. So this is a truss. So we'll see how to analyze this truss using method of joints. This is a trigonometric table. In this example, I will use the values of this table. So our first task is to find in support reactions, which are AX, AY and dy. So first I am going to take all the horizontal force component. So if I take the sum of all the horizontal force component, you can see there are only one force component. So that means this AX equals 0. So this AX equals 0 means this AX force is useless. So consider this is don't exist. So now if you closely observe this truss, you will see there is a symmetricity of this problem or this truss. So you can see there are 3 kilonewton forces on both sides, and at the middle of the truss there is a 2 kilonewton, and there are support reactions on both sides, right? So my next task is to find in AY and dy, and please keep in mind this is a symmetric truss. So due to this symmetricity, I can say AY equals dy. So next I am going to consider sum of all the vertical forces. So if I consider vertical forces, I can write AY plus dy equals 3 kilonewton, 2 kilonewton and again 3 kilonewton. If I simplify this, I can get AY plus dy equals 8. Since AY equals dy, I can say AY equals 4 Newton and dy equals 4 Newton. Actually not Newton, they are kilonewton. So now I found all the support reaction of this truss. So due to symmetricity, I can say member force of AG equals member force of ED, right? Then member force of AB equals member force of CD. Member force of GB equals member force of CE. Member force of GF equals member force of FE. And finally, member force of FBF. FBF means this member. Member force of this member equals member force of FC member. So that means we just have to find one value, which are these 3 values, and these 2 values I have to find. Okay, now we will see how to apply method of joints for this problem. First I will consider joint A. So if I consider joint A, there are 3 forces. So first this support reaction, and then member force of AG, then member force of AB. So I marked it here 3 forces, and this angle is given in the diagram, it's 30 degrees. how I marked direction of these forces. So we know this 4 kN force is exactly upward. So in order to balance this force, there should be a force for downward. So considering this force, I can say this FAG force is directed to this direction, not this direction, right? So this FAG force, we consider this FAG force. If I consider horizontal component of this FAG force, it goes this direction. So in order to balance this force, I should mark this FAB force for this direction, right? So that is the equilibrium of this joint, right? So I marked these forces considering equilibrium of the joint. But there's a easy way. I will teach you two methods, method 1 and method 2. You can use either method 1 or method 2. You can't use both methods at the same time. So method 1 is mark all member forces as they direct away from the joint. Like this diagram, forces marked directed away from the joint. Then do the calculations. If you get positive answers, member is in tension. If you get negative answers, member is in compression. That is the method 1. Method 2, mark all the member forces as they direct towards the joint. Like this diagram, all the forces marked towards the joint. Then do the calculation. If you get positive answers, member is in compression. And if you get negative answers, member is in tension. So you can use method 1 or method 2. So if you use those methods, you don't have to worry about the equilibrium of joint. Just mark the member forces and do the calculations, and according to plus or minus you can decide compression or tension. Okay, now I'm going to do the calculations. So first I'm going to take all the vertical forces, sum of all the vertical forces. So if I consider vertical forces, first I can write plus 4, then vertical component of this FAG force. Vertical component of this FAG force is FAG sine theta. So theta is 30 degree here angle. So I can write FAG sine 30. So instead of sine 30, I can write 1 over 2 from trigonometric table. Then I can simplify this and get FAG equals 8 kilonewton. So this FAG force is marked towards the joint. So I got plus answer. That means this FAG force is a compression force. Then I am going to take the sum of all the horizontal forces. So first horizontal force is FAB, so I marked it here minus then horizontal component of this FAG force, so that is FAG cos 30. So now I know value of FAG, it's 8. I found it here and I substitute 8 instead of FAG and simplify it. So instead of cos 30 I can write square root of 3 over 2. Then I simplify this and I can get FAB equals 6.928 kilonewton. And FAB is directed away from the joint and answer got as plus value. So that means FAB is a tension force. So that is joint A. Next I am going to consider joint G. Here this is the joint. You can see FAG, this force is this member force, and FGB member force is this member force, and FGF member force is this member's force, and 3 kilonewton is the point load. So if we consider angles, angle between FGF and FGB given in the diagram, but this angle is not given in diagram, you have to find it. So I will show you how I got this 60 degree angle. For that I am going to draw a line through this joint, vertical line. So this is a 90 degree angle or right angle. So if we consider this triangle, right? If we consider this triangle, so I will erase it. If I consider this triangle, this angle is 30 degree and this angle is 90 degree, and that means this angle is 60 degree, right? This angle is 60 degree and this angle is 60 degree as well. It is given in the truss. And if I consider this overall angle, it's 180 degree. It is obvious, no? It is 180 degree. Now I mark here as theta, so I can write the equation theta is this angle and plus this angle, it's 60 degree, and now this angle, it's also 60 degree, and it's equals to 180 degree. So if I simplify this, I can get theta equals 60. I hope you got the idea. So that's how I got this 60 degree angle for this angle. And I'm going to consider this plane and this plane. So I will erase it all the writings. Okay. Previous joint I consider vertical direction and horizontal direction. So in this joint I consider this plane and this plane. That's why I need those angles. So I marked it here. You can see this is the y-axis and this is the x-axis. So if I draw a line here, I showed you how I got 60 degree here. Since this is a right angle and this is 60 degree, I can say this is 30 degree angle. So that's how I find angles of this problem. So now I show you how I do calculations. So this is the joint as I showed you before. First I am going to consider forces along this y-axis, right? You can see this arrow. I will consider this direction. So I will consider this direction. You can see there is a force of FGB sine 60. So that is this force FGB sine 60. So this is the this component of y component of this force, and minus 3 cos 30, that is this this force. Y component of this 3 kilonewton force is 3 cos 30. So I wrote it here, and I simplify this. I can get FGB equals 3 kilonewton and its compression force. So for sine 60 and cos 30, I can substitute values from trigonometric tables. Then and also please keep in mind, if I consider this y-axis direction, I don't have to worry about FAG and FGF. No need to consider those forces because they are right angle to this axis. Next I am going to consider x-axis direction, right? So here I can write this force FAG. So instead of FAG, I substitute value of 8 because in previous calculation at joint A we found FAG equals 8. Then minus 3 sine 30, that is this x component of this 3 kilonewton force. So it's 3 sine 30 minus 3 cos 60, that is FJB component. So if you get the x component of this FAG force, you can write FGB cos 60. So I wrote it here as 3 cos 60 because value of FGB is 3. then minus GF, that is this force. So if I simplify this equation, I can get FGF equals 5 kilonewton, and it's a compression force. Finally, joint B, this joint. So I have to consider this AB member force, BC member force, BF member force, and BG member force. So you can see there are 4 forces associated with this joint. Now I know FAB force and FGB force. I just have to find FBF and FBC. For that, first I will consider sum of all the vertical forces. So I have to write FBF sine 60 minus 3 sine 30, that is this force. If I get vertical component of this force, I have to write 3 sine 30. Then I simplify this and get answer as FBF equals 1.73 kilonewton, and it's a tension force. Next I am going to consider sum of all the horizontal forces. So I have to write FBC plus 1.73 is FBF, this force FBF cos 60 plus 3 cos 30, which is this force. If you take horizontal component of this force, we have to write 3 cos 30 minus 6.928, that is this force. So if we simplify this, we can finally get FBC equals 3.46 kilonewton, and that is a tension force.